In lecture 1, we have started the fundamental formula application. It means application of the fundamental formula in integration. And in this lecture 2, we are starting the substitution. Everyone, substitution is very important part. And let's start. Let's see what is the substitution. First of all, suppose integration of x plus 1 whole to the power 7. We have to integrate x plus 1 whole to the power 7. How to proceed? How to do the integration? We'll substitute x plus 1 for some, we'll replace x plus 1 for some t or z or whatever, and we'll get the fundamental formula. Okay, so what to do? In this case, let's apply ddx on the both side. So this is 1 and this is coming dt by dx. Actually, we are not doing the differentiation, we are doing the differential. Okay, just for very basic understanding, we are using the differentiation. Differential क्या है? Differential का मतलब let's do the differentiation with respect to the x, and in the right hand side we'll do the differentiation with respect to the t. Okay, that is the main target, not differentiation. Target is the differential. Okay, so in this case, since it is a very beginning, so I am showing you the differentiation method. Actually ऐसे करना पड़ेगा. ddx left hand side का derivative with x and right dx, right hand side का derivative with t, right dt. Okay, so this is the differential method, it is called. It is some other differentiation with respect to itself. So what we'll do here, in this case we can write, we'll replace everything because it is a one variable, calculus is a one variable operator. So it's some other, whenever x with dx, whenever t with dt, x and t, x and y will never coexist. Okay, that should be our target. So what we'll do now, that is t to the power 7 dt. In place of dx, we are putting dt. Now x plus 1 will replace in terms of dt. So total one variable is we got. Okay, so in this way we'll proceed. So what to write here? In this case I am writing t to the power 8 by 8 plus c. अभी t का value put करो. So x plus 1 whole to the power 8. So most important part of the integral calculus is the substitution, and in entrance examination difficult to difficult questions are coming based on this substitution method. Okay, so let's solve. What we'll do here, suppose another question number 2, integration cos of log x by x dx. So we have to search that whose derivative is present in the sum. Whose derivative is present in the sum. Okay, and we'll take that as t, and we have to replace that its derivative by dt. For example, in this case, there is no derivative of cos x. Cos x का derivative क्या होगा? That is minus sin x. So sin x is not present here. But log x का derivative of log x is 1 by x. It is present. So what we'll do? Let log x equal to t. So dx by x equal to dt. Therefore, I can write here that cos t dt. Cos t क्या होगा? That is sin t plus c. Sum over. Okay, everybody. Next question. Suppose if I write tan of e to the power x into e to the power x dx. So first of all, we have to search whose derivative is present in the sum. Tan ka derivative to x square, then it's not present here. So the derivative of e to the power x is e to the power x. Therefore, we have to consider e to the power x equal to t. Therefore, I can write here that let e to the power x equal to t. So e to the power x dx equal to dt. Therefore, tan t dt, we are getting log sec t. Next time coming, integration of e to the power sin x into cos x dx. Once again that concept that whose derivative is present in the sum, तो यहाँ पे हम लोग देख रहा हूँ that sin का derivative is cos. So let us consider sin x equal to t. So what we'll write? Let sin x equal to t. So cos x dx equal to dt. Therefore I can write here cos x dx is dt e to the power t. Therefore e to the power t plus c. Right? One more question. Suppose if it is 2x plus 1 whole to the power 80. Here it is a single power of x. Since it is a single power of x, so its derivative of the x is 1. So nothing to be replaced. Simple. Whatever there, 2x plus 1 equal to t. Therefore we can write here, let 2x plus 1 equal to t. Therefore 2 dx equal to dt. So I can write here t to the power 2 is out. So dt 2 dx equal to dt. So dx equal to dt by 2. So I am writing here 2. So t to the power 80 dt. So whenever t is there, we have to write everything in terms of t. We have to replace everything in terms of t. Whenever it is x there, we have to write everything in terms of x. Okay. So I can write here half t to the power 80 plus 1 by 80 plus 1, and always the integration constant is present here. Now t ka value put karo. We are getting what? That is half t. T means 2x plus 1 whole to the power 81 by 81 plus c. This is the final answer. I am going to the next sum. Integration sin square x by cos to the power 4x. So everybody always will not get, remember one thing, always will not get that direct replacement. It means direct substitution. It's another, whatever you are thinking as t, its derivative is present. Always it should not be present. Okay, so we have to think that whatever we are thinking as, exactly it is like a chess game. We have to think that whatever we are thinking to take as t, its derivative is present in the sum. Therefore I can do here, what will that? I am bring this sin square x by cos square x, that is tan square x, and 1 by cos square x I can take it up, that is sec square x. Therefore I can write here integration of, once again I am writing tan square x into sec square x. What will do? Let tan x equal to t, because its derivative is present in the sum. So I can write here, let tan x equal to t, so sec square x dx equal to dt. So sec square x dx के जगह पे dt, and tan x is t square. T square, its integration is x to the power n plus 1 by n plus 1. So t to the power 3 by 3 plus c. Therefore final answer is what is coming? The tan x whole to the power 3 by 3 plus c.